Hello everyone, welcome to finmanac.com. This is a series of lecture in simple equations, and I'm going to continue to use the same concept of difference in age being constant and solve a few more sums. The statement that I've written may be a little difficult to comprehend at the first go, so I would suggest you, after I read the statement, you pass it for a couple of minutes and understand for yourself and form an equation before we proceed. A says to B, I was 5 times as much as you were when I was your age. The sum of the present ages of A and B is 140. What is the difference? Now, the important thing is to interpret what is within the quotes. I was 5 times as much as you were when I was your age. Please go ahead and attempt to solve this by framing an equation for the first statement within the quotes. I sincerely hope that you might have tried doing the same by passing this video. So I will try and attempt to solve this question by breaking this within the quotes into two parts. I was 5 times as much as you were when I was your age. I'm considering the second statement, which is when I was your age. So A says to B, when I was your age, which means A is B's present year. I've taken a simple example which will explain the concept which is in the problem itself. This is a most important approach for any problem. If you don't understand the statement, try and take an example and see how it works, and then you can plug the values for the sum itself. So I have the present age, past age, and the difference for two people A and B. I've assumed the present age of A to be 25 and the present age of B to be 22. And if A is saying to B the present age of A is the same as what is B is, so I'll have the past age of A to be the same as B's age, which is currently 22. Now I need to actually find out what will be the age of B when A is 22 years old. If you ask anybody, this is very easy. They will immediately say that it is 19. But let's understand the process how they got this. It is nothing but they find out the difference between 25 and 22, that is 3, and then they might have subtracted from the value of the present age of B, which is 22. So 22 minus 3 giving 19. This is a process they get it. So first they get the difference between the present age and the past age of A, and that difference should be subtracted from the present age of A, from present age of B. The reason why we do is because we all grow by the same age. So when A is 25, B is 22. When A was 22 years old, B would have been 19 years old. That's what the meaning of the statement is. So now coming back to the problem, I have the present age of A to be A and that of B to be B. So when A was B years old, what will be the age of B? I've done the same thing. I've taken the difference between the present and the past age of A to be A minus B, and I have subtracted that from B itself, that is B minus A minus B. That becomes 2B minus A. If you get this concept of 2B minus A very clearly, you will understand the rest of the problem to be very simple. I've captured the values to be by equating from the first statement, which is I was 5 times as much as you were. So I was for 5 times is interpreted as B is equal to B being the age of A when A was B years old, and 5 times being 5 times that of the age of B, the age of B that I've calculated when A is B years old to be 2B minus A. So I have this equation solved as B is equal to 10B minus 5A, 5A is equal to 9B, and A by B is equal to 9 by 5. This means the ratio of A is to B is 9 is to 5, and I'll have the value to be 9K and 5K respectively. After this, it's a matter of solving. If you know ratios, you have to take it as 9K and 5K, and the sum to be 140, the value of K will be 10. You can substitute the value for K to be 10 here. I'll have it as 90 and 50, so I can find the difference to be 40. So that ends the sum. Now let's go ahead and change some of these values and see how the problem was created. So I'm going to change this as 4 instead of 5, and can you guess the value here? What will be the value here? So what is that I'm trying to say? It is just how much should I consider for my present ages of A and B such that their difference in age is going to be an integral value. So I've taken it as 110. You will understand why I did that. Everything remains the same except for the fact that in this I'll have it as 4 times instead of 5 times, and this will become 8b minus 4a will be the value of that, and the sum proceeds the same way as the previous one. It will become 4a is equal to 7b, or rather a by b is equal to 7 by 4. This means the ratio of a and b to be 7:4. This is the reason why I have taken this to be 110. So you understand that 7k plus 4k is 11k, so I could have taken it as any multiple of 11. So I've taken it as 110 instead of 140. So that being the idea, now you know that the value of k still remains 10 from the previous calculation. So a's value will be 70, b's value will be 40, and the difference will be 30. Yeah, so you can go ahead and try for various other values of a and b, which is going to be 3 times. You can try it for 3 times, and you can try it for 5, 6 times, everything. But the only concept being, what should be the sum of the ages of a and b such that the difference is an integral value, and the other concept being the difference in age is constant. Across the row and across the column we have the ages difference to be constant, and that is a fundamental concept tested in any ages problem, be it data sufficiency or be it a normal problem. Thanks for listening to this, and I hope you enjoyed this and practice more problems of this type. We'll come back for more questions on simple equation. Thanks a lot.